Hi, in this second video, I'm going to talk about another quick example of using an LLM to talk to a relational database. And then I'm going to talk about something that's a strength and a limitation. So I usually pick one theme in each of these videos. These videos are designed to be pretty quick. And today I'm going to be talking about hallucinations a little bit. So what I'm going to do here, what you're seeing on the screen is this project I've been working on called GPT. That is a lightweight sort of application that allows you to talk to databases and locally. So here on my laptop, this is running locally. And what I'm going to do is I'm going to not use a CSV file. I'm going to go to SQL. And there is actually an online version where you can connect to Azure. And there's an online demo. There'll be a link below this video to that. But for this purpose, I'm actually going to switch to local SQL. So I have a SQL instance on my network that I can access, and that has a few databases. I'm going to use Chinook as an example. It's a database with more than 5 tables. It's a little bit of a complex schema. You kind of have to traverse different tables to answer questions. But anyway, so I'm going to go to the Talk tab and ask it a question. And this tells me that it's connected to which server, which database, and using GPT 3.5. I'm going to ask it what are the total album sales. So this data is about musical artists and the sales of their albums by country. Okay, so total album sales by country, I'm going to ask it. And the idea here is that I can type in a question, and the LLM, which in this case is GPT 3.5, can figure out on the server. So I give it the SQL server. I also give it a database. It'll figure out what are the right tables to ask the question of, and then structure the query. And here, so it gives us an answer here in this window, in the chat window. And then the code portion gets carried over here. And sometimes the code portion gets edited to make it run better a little bit behind the scenes. I'll talk in a future video about what those edits are. But here, let's see. So it's written the code. It's importing a package. Pandas is writing a SQL query. I actually don't remember the exact schema, but it seems right. So I did intend for it to look for the customer country, but that's where the sales are. So it seems like that's what it's doing, the customer database. In order to get um, the the total sales, you kind of have to go to a track table. So that's here to get the unit price and quantity. So there's no column called total sales. So it kind of has to figure out that, oh, I need to multiply unit price by quantity to get total sales, which is interesting that it was able to figure that out. That was not an explicit instruction behind the scenes. And I'll talk in the future video about what instruction is behind the scenes. Basically, it's just a schema, which is a bunch of tables and what columns names are in the table. No actual data gets shared with the LLM in this case. Okay, so let's run this and see what it looks like. This is an editable code, so I'm going to edit it. For example, instead of printing it, I'm just going to ask it to display the data frame. So execute. Okay, so check the data frame below, and here we have it. So different sales, so that's pretty good. Okay, all right, so this video is getting a little long, so maybe I'll go straight to hallucinations. And I wanted to show some world mapping graphical abilities, but I'll do it in a future video. But let me talk a little bit quickly about hallucination. Hallucination is a big problem with these models, right? So especially when you're using them to generate text, like you're summarizing documents, you're asking it to write responses to something, drafting emails, and so forth. Even if you give it the context, so there's something called RAG, retrieval augmented generation. So you can kind of give it, also called RAG. Behind the scene, can give it a bunch of documents and context about yourself, your business, or whatever is relevant for it to generate the content. It does a good job, but it can insert things into it that aren't real, names, all kinds of things. It basically can hallucinate, which becomes difficult because then now you have to really carefully review it before you use it. In this case, hallucinations are interestingly mitigated in a sense because all it's doing is generating code. Now, if it hallucinates and makes up this column that doesn't exist in my data, the code will error out and will not produce an output, right? So, in that sense, it's mitigated. But in a more complicated sense, it's actually the errors of interpretation are going to be harder to spot. So errors of execution will be easy because the code will just fail, which is great, right? So if it generates bad code, it just won't run. But if it interprets the user question wrong, and the code will run, and let's say it just summarizes unit price, which has happened before, it just calls that unit sales. Then we will say instead of 523 sales for USA, we might have like 2 sales for USA, and the user, if they don't know the schema themselves, are not going to be able to spot that. So that's sort of the difficulty here. And as these models improve, as these LLMs improve, now if I use GPT-4, maybe it won't make that mistake. Maybe 99% of the time, or maybe ever, but GPT 3.5, it does make that mistake. And if the models continue on the rate of improvement that they are, then maybe those errors of interpretation will be greatly mitigated also in the future, but that remains to be seen. That's an area of active research. Anyway, I think I'll cut this video short right there. If you have any thoughts, if you disagree with anything I said, if you have any tools that are really interesting in this area of talking to databases, um, do comment below the video. Let me know if there's any questions you have that you want me to explore in future videos. Let me know that as well. Thanks for watching, and I'll see you in the next one.